What if I told you that right now, as you watch this, thousands of space rocks are zooming past Earth at unimaginable speeds? Some are small, harmless pebbles, but others, they could be planet killers. 66 million years ago, a 6-mile-wide asteroid wiped out 75% of life on Earth, including the dinosaurs. And despite what many people believe, we're not out of the woods yet. In fact, as of this year, scientists have identified over 27,000 near-Earth asteroids, and some are coming dangerously close. Welcome to What Happens If, where we explore unbelievable scenarios based on facts. If you love exploring the what-ifs of the universe, make sure to like this video, subscribe, and hit the notification bell so you never miss an episode. Today, we're exploring the terrifying reality of what happens if an asteroid hits Earth. But before you breathe a sigh of relief thinking, that's not happening anytime soon, think again. Because on April 13th, 2029, an asteroid the size of the Empire State Building will pass by Earth at just 30,000 miles, closer than some satellites. And that's just the beginning. So, what would really happen if a massive asteroid were on a collision course with Earth? And more importantly, are we prepared to stop it? Let's find out. First, let's rewind 66 million years. The day everything changed, a single asteroid changed the course of life on Earth forever. A massive asteroid, estimated to be 6 miles wide, traveling at 45,000 miles per hour, slammed into what is now Mexico's Yucatan Peninsula. The impact released energy equivalent to 10 billion atomic bombs, instantly destroying everything around it. The explosion sent shockwaves across the planet, igniting global wildfires, while tsunamis over 300 feet high swallowed coastlines. But the real catastrophe came in the form of an impact winter, where debris and soot blocked sunlight for up to 20 years, causing a global temperature drop of 18 degrees Fahrenheit. With plants unable to photosynthesize, the food chain collapsed, and life on Earth faced its greatest extinction event. Now, here's something most people don't realize. The dinosaurs didn't all die instantly. While many perished in the initial blast, countless others survived the impact only to starve to death in the months and years that followed. As plant life disappeared, herbivores died off first, followed by carnivores that had nothing left to hunt. This was the beginning of the end for the dinosaurs, wiping out 75% of all life on Earth. Could history repeat itself? Let's talk about the asteroids floating nearby in space. Right now, thousands of asteroids are classified as near-Earth objects, NEOs, space rocks that come within 30 million miles of our planet. Some of these objects are harmless, but others might be dangerous if their orbits shift toward Earth. To keep track of them, NASA, ESA, and other space agencies rely on powerful telescopes like NEOWISE and AI-driven tools like Thor, which recently identified 27,000 previously unobserved asteroids. And next year, the Vera C. Rubin Observatory, launching in 2025, will go online, drastically improving our ability to detect and track these space rocks. But the surprising part, while astronomers have tracked over 90% of large asteroids, those 1+ mile wide, smaller ones, like the 65-foot asteroid that exploded over Chelyabinsk, Russia, in 2013, can still slip through the cracks. That explosion released energy 30 times more powerful than the Hiroshima bomb, injuring 1,500 people and damaging 7,000 buildings. And that brings us to a particularly famous asteroid, Apophis. On April 13th, 2029, the asteroid Apophis, measuring 1,000 feet wide, will pass by Earth at a distance of just 19,000 miles, closer than some satellites in geostationary orbit. For context, that's 10 times closer than the Moon, and close enough that it will be visible to the naked eye in some regions. While Apophis won't hit us this time, this rare flyby provides a crucial opportunity for scientists to study it in detail. NASA will use its Goldstone radar, and ESA plans to deploy the Ramses mission to analyze its surface and trajectory. Some scientists speculate that Earth's gravity might even slightly alter its future path. If Apophis, or a similar asteroid, were ever on a direct collision course, the impact energy could be equivalent to 1,200 megatons of TNT, enough to flatten a major city and cause devastation on a regional scale. So, if an asteroid were actually heading straight for us, what could we do? If an asteroid was on a direct collision course with Earth, could we actually stop it? Contrary to popular belief, blowing up an asteroid like in the movies isn't the best plan. That would just turn one giant rock into thousands of smaller ones, all still heading for Earth at high velocities, potentially increasing the overall damage across multiple locations. Instead, scientists are developing planetary defense strategies to nudge asteroids off course before impact becomes inevitable. The most successful test so far was NASA's 2022 DART mission, which slammed a 1,260-pound spacecraft into the asteroid Dimorphos, altering its orbit by 32 minutes, far more than expected. This proved that kinetic impactors could be a viable defense method. Other proposals include gravity tractors, spacecraft that hover near an asteroid, using their gravitational pull to slowly change its trajectory. This technique requires years of lead time, but avoids the risk of fragmentation. But if time is too short, some experts argue that nuclear deflection might be the only remaining option. This remains controversial, as a nuclear explosion could shatter the asteroid into random pieces, some of which could still strike Earth. Scientists are actively debating the risks and benefits of such an approach. If a massive asteroid hit tomorrow, the devastation would be unlike anything in human history. Let's say a mile-wide asteroid was heading straight for us. What happens next? First, governments and space agencies would quickly try to find out the exact impact location using satellite tracking, ground-based telescopes, and AI-powered simulations. The speed, angle, and composition of the asteroid would determine the scale of destruction. If it hit an ocean, it could trigger a tsunami hundreds of feet high, slamming into coastlines and wiping out coastal cities. The 1883 Krakatoa eruption created waves over 130 feet high, and an asteroid impact could be even worse. If it struck land, the explosion could release millions of megatons of energy, flattening everything for hundreds of miles. The 1908 Tunguska event, caused by a 130-foot-wide asteroid, leveled 800 square miles of forest, an area larger than New York City. A city-sized asteroid could wipe out an entire city, while a 20-story asteroid could destroy an entire nation. And what about a 6-mile-wide asteroid, like the one that wiped out the dinosaurs? That would be a global catastrophe. The impact would send trillions of tons of dust and ash into the atmosphere, blocking sunlight for years. Without sunlight, temperatures would plummet, crops would fail, and ecosystems would collapse worldwide. The result? Mass extinctions, just like what happened 66 million years ago. How prepared are we really? This is where planetary defense comes in. Organizations like NASA, ESA, and the International Asteroid Warning Network follow a 5-step approach. The first step is detection, which involves finding asteroids before they find us. Once identified, the next phase is observation, where these celestial objects are tracked for months or even years to determine if they pose a threat. After tracking, the third step is defining, which means studying the asteroid's composition and movement to develop an effective countermeasure. If an asteroid is on a collision course with Earth, scientists move on to deflection, testing various techniques such as kinetic impactors, gravity tractors, and, if necessary, nuclear deflection. Finally, the 5th step is emergency planning, which ensures global coordination to minimize casualties if an impact becomes inevitable. To raise awareness about these threats, June 30th is now recognized as International Asteroid Day, serving as a reminder that preparation is key. While Earth has been fortunate so far, the truth remains. Luck is not a defense strategy. So, should governments be taking asteroid defense more seriously? Drop your thoughts in comments below. With 27,000 near-Earth asteroids discovered in recent years, the risk isn't just science fiction. Even though NASA's DART mission proved that we can alter an asteroid's trajectory, we still lack a fully developed planetary defense system. A future impact might not be a matter of if, but when. If you found this video fascinating, hit that like button and subscribe for more mind-blowing what-if scenarios. Until next time, stay curious, stay prepared, and keep looking up, because space is full of surprises.